All right, let's jump right into one of the most fundamental skills in algebra, writing the equation of a parallel line. Now, I know it can sound a little intimidating, but trust me, there is a super simple foolproof method that's going to work every single time. Let's get into it. Okay, this right here, this is the most important idea of the whole explainer. You have to get this in your head. When we're given a reference line, we honestly don't care where it is on the graph. Its position is irrelevant. All we want from it is its direction. Think of yourself as a spy. Your mission is to extract one piece of intel, and one piece only. And that intel is the slope. So what is this direction we're trying to steal? Well, in the world of math, we just call it the slope. It's that little m in our classic y = mx plus b equation. It tells us everything we need to know about how steep a line is. And here's the key. Parallel lines, by their very definition, have the exact same direction. That means they have the exact same slope. And this is the only process you will ever need. Seriously, I call it the copy-paste method, and it's just 3 incredibly simple steps. 1. Find the slope of the original line you're given. 2. Keep it. Literally just copy it over. Don't change a thing. And 3. Use that copied slope and the new point they give you to write your new equation. That's it. Find it, keep it, write it. Okay, you ready? Let's put our copy-paste method into action. We're going to start with the most standard type of problem you'll see. This is our basic playbook. So here's our mission. We've got a reference line y = 4x minus 2 and a specific point our new line has to go through, which is 1, 3. Time to fire up the copy-paste method. Step 1, find the old slope. And hey, look at that. The equation is already in that beautiful y = mx plus b format, so the slope is just sitting there, plain as day. It's the number right next to the x. The slope is 4. Easy enough? And now, let's knock out steps 2 and 3. Step 2, we keep that slope. No questions asked. Our new slope is also 4. Step 3, we write the new equation. Now, the easiest way to do this is almost always the point-slope formula. You just plug in your new point and your new slope. So we take our slope of 4, our point 1, 3, and boom, there's our answer. Y minus 3 = 4 times the quantity x minus 1. Done. Okay, that was the warm-up. You're feeling good, right? So let's level up. What happens when the problem tries to get a little tricky? What happens when the slope isn't just handed to you on a silver platter? Take a look at this one. Our reference line is x plus y = 5, and our new point is 2, -1. Now, you'll probably notice right away that equation looks different. It's in something called standard form, and that means our slope is hidden. To find our hidden slope, we've got to do a tiny bit of detective work, which really just means a little algebra. Our goal is to rearrange this thing back into that comfortable y = mx plus b format. And to do that, all we need to do is get y all by itself on one side of the equal sign. So to get y alone, we just subtract x from both sides of the equation, and that gives us y = -x plus 5. And just like that, the disguise is off. The slope is revealed. It's the number chilling in front of the x, which in this case is -1. And you know what? From here, the game is exactly the same. The hard part's over. Step 2, keep the slope. Our new slope is -1. Step 3, use that slope and our point, 2, -1, in the point-slope formula. A little simplification, and we've got it. Y plus 1 = -1 times the quantity x minus 2. All right, time for a really interesting special case. We know how to handle lines that go up or down. But what about a line that goes straight up and down? You know, a vertical line. Its slope is technically undefined. So how in the world do you copy a slope that isn't even a number? So here's the scenario. Find a line parallel to x = 3 that passes through the point 5, 2. Now, that equation x = 3 might look a little weird, but all it means is a perfectly vertical line where every single point on it has an x-coordinate of 3. So for these vertical lines, the whole idea of slope kind of breaks down. So you know what? We can just ignore it. The logic is actually way simpler. If the original line is vertical, any line parallel to it has to be vertical too. And all vertical lines have that same format, x = some number. We just need our new line to go through the point 5, 2, so we grab the x-coordinate from that point. The equation is simply x = 5. That's it. You know, knowing the right steps is half the battle. The other half is knowing what not to do.
So let's quickly cover the two most common traps people fall into so you can just sidestep them completely.
The first and by far the biggest mistake is getting greedy. Remember that spy mission? We are only there to steal the slope, the m. Some people accidentally grab the y-intercept, that b value as well. But that's a huge mistake. The new line is in a completely different place. The only thing they share is their direction. Just take the slope and get out. And trap number 2 is mixing up your rules. It's so easy to do. For parallel lines, that's what we're focused on today, you just copy the slope. That's it. M new equals M old. But for perpendicular lines, you have to do something totally different. You have to flip the slope and change the sign. Don't mix up those two playbooks. Today, we just copy. So why are we even doing all this? I mean, does this stealing slopes thing ever actually show up outside of a math class? Oh, absolutely. Let's look at a really cool and very visual real-world application. You see this math come to life in places you would probably never expect. If you've ever used graphic design software to, say, put a border around something or create a cool drop shadow effect on some text, you have used parallel lines. To create that effect, the software is literally calculating a new path that's perfectly parallel to the original shape, just shift it over a bit. Look, mastering this isn't just about passing your next quiz. This core idea, using a known rate of change, a known slope, to describe something brand new, is a massive building block for more advanced math. This is a direct preview of some really powerful concepts you're going to see down the road in subjects like calculus. So we'll end with a thought. Today, we learned how to steal a line's direction to define a brand new parallel line. And it kind of makes you wonder, what other properties could you borrow from one equation to define a completely new one? Something to chew on. Thanks for tuning into this explainer.